So, our first example problem in this lesson asks us to compare the graph of g of x to the graph of f of x. And g of x is 4x squared and f of x is x squared. This function f of x equals x squared is referred to as like the basic standard parabola. That's if people ask you what is the shape of that, you would say it's your general parabola shape. That's what it's going to be. So since we're going to compare the graphs of these, what I want to do first is make a table of values showing what g of x is. And I'm going to again put in values that range from -2 to 2. And that's what I'm going to ask that you guys do whenever you graph your parabolas. This point 0, whenever we put 0 in and square it and get 0 and we multiply it by 4, you get 0. This point is going to be your vertex point. And I'm going to ask that you set up your table so your vertex point is always in the middle of the table. The reason I want you to put it in the middle of the table is because the values to the left and to the right of it are going to be symmetric. If you go 1 to the left, it's going to get you a y value that's the same as the y value if you go 1 to the left. If you go 1 to the right, the y value is the same as if you go 1 to the left. So these two y values better be the same. You'll see that they are. Let's put in an x value of 1. 1 squared is 1. 1 times 4 is 4. If we put in -1, square -1. -1 times -1 is 1. 1 times 4 is 4. You can see those two values are the same. Likewise, that's going to occur with both of these. So in essence, if you realize that, all you have to do is calculate half of the ones on one side of the vertex, and you've already found the other half on the other side of the vertex. So let's just put in one of these two. I think most of you would agree that dealing with positives is usually nicer. So let's put in 2. 2 squared is 4. 4 times 4 is 16. So that means this is 16. If you have your doubts, you can substitute -2 in and you'll see that you also get 16. Now, on the same table, I'm going to put the values for f of x so that I don't have to spend more space because space is very limited here. So I'm going to put 0 in to this. 0 squared is going to be 0. And now I'll put in 1. 1 squared is 1. The symmetry tells me this is going to be 1. Now I'm going to put in 2. 2 squared is 4. And the symmetry tells me this is going to be 4. So there's the values for f of x. We can see right now, if we're comparing them, that the vertex values are the same and the y values are differing by a bit. These values seem to be getting larger more so than these are. And you'll see what happens in the shape. So we're going to graph both of these on the same set of axes. So let me realize here, before I draw my axes, I'm never ending up with any negative y values. So I'm going to set up my graph so that I'm only using the positive part of the y-axis. My x values, I only go 2 to the left and 2 to the right on my x-axis. On my y-axis, I have to go 16 up. So this is the space I've allowed for myself to go up 16. So I'll put that as 16. And what I'm going to do is split that in half, and I'll call that 8. Then I'll split each of these in half. When I split that in half, that tells me that's 4. And I split that in half, that's 4 above 8, which is 12. And then I have to count to 1. So I'm going to split that in half and then that in half again. So here's 2, here's 1. And just to be consistent, I'm going to do the same on all of those. That's not necessary to do. That's just me being particular, that's all. Alright, so let's graph g of x. I'll graph g of x in green. G of x has this vertex point of 0, 0. And it has over 1 up 4, over 1 up 4, that point right there. And what I like to do is graph these 2 points together. So 1 to the left, 4 up, 1 to the left, or I'm sorry, 1 to the right, 4 up, 1 to the left, 4 up. So I'm going to put that point right there. 2 to the right, 16 up, I'm going to graph at the same time I graph that. 2 to the right, 16 up, 2 to the left, 16 up. So right there. And right here is a sketch of that function g of x. Right there. So let's now, on the same set of axes, plot f of x. I'll graph f of x in red. Alright, so I'm going to plot the vertex first, which is 0, 0. Then I'm going to plot the point over 1, up 1, which is right here. And I'll do those 2 points in conjunction, so I've got that point right there. And then I'll plot the over 2 up 4 and the over 2 to the left up 4, which takes me right here and right there. And now I'll sketch this parabola. Whoops. Right there. There's our function f of x. So now what we can do is visually compare them. What I think you would say, I think first and foremost, is both open up. Both f and g open up. I think the next thing you might say is about the shape. I would say that g of x is more narrow than f of x. Wouldn't you? It's a much skinnier parabola. The other thing we can say is both have a vertex of 0, 0, and both have a line of symmetry, an LOS, a line of symmetry of, do you remember what the equation is for the y-axis? What's the same on every point on the y-axis? The x value is 0. They both have a line of symmetry of x equals 0. They both increase and decrease in the same spots. Look, if we hop on this, we're going down. We're going down. Where are we going down? We're going down where x is less than 0. So we could say they both decrease when x is less than 0. Once you get beyond 0, if you're going left to right, you're increasing on both of those. And we can say they both increase where x is greater than 0. Now, really the main difference, if we're asked to compare them, the main difference between them is this. Everything else is the same. So in essence, if I'm asking you to compare two, I just want to know what the differences are. That's all you have to give me. You don't have to give me that other information. In the next video, I'm going to talk about how to know what's going on with the shape by comparison, just by looking at the graph's equation, or I'm sorry, the function's equation. We'll be able to determine that just from looking at the equation.